start the recording. So yeah, this is the next lecture for the atomic physics chapter. Here we have a comparison table for alpha, beta, gamma. Read this up. If you have any question, you ask me. What is ionization? I'm gonna come to it in a little bit. So if the ionizing thing for the time it doesn't make sense, let it go. I'll explain this in detail after just a while. Read them through.
স্যার অ্যালফা কি স্কিন পেনিট্রেট করতে পারে?
Alpha?
স্কিন পেনিট্রেট করতে পারে হিউম্যান স্কিন মানে চামড়া?
I mean, it can penetrate a very small thickness of the skin, so it might actually go through the dead skin, dead cell layer of your skin, but eventually it can get into your alive skin. So the answer is yes, but it's not gonna be like X-ray that's gonna penetrate from skin to skin and eventually leave out of your body. Not like that. It can get in and stay there.
Sir?
Yes.
স্যার আলফা পার্টিকেলসে যে হিলিয়াম হিসেবে ধরা হয় যেহেতু দুইটা প্রোটন আছে দুইটা নিউট্রন আছে, এটা যেহেতু পজিটিভ মানে কোনো ইলেকট্রনস নাই।
Okay, go ahead.
না স্যার এটা কোশ্চেন ছিল, কোনো ইলেকট্রনস নাই
না,
হিলিয়াম।
হ্যাঁ,
ওকে
হ্যাঁ, yes, that's the structure of the alpha particle.
Okay.
Sir, if we are struck by a beta radiation, will it feel like an electric shock? Because
No.
they are electrons.
No. As long as we are under the effect of ionizing radiation, we would not feel anything. But until we start to experience the after effect of getting too much ionizing radiation, which is skin burn, or later down the road we can have tumor growth or cancer cells growth, something like that. But immediately you would not feel any shock sensation, but you might get some burning sensation if the radiation value is too high.
Either radiations can be it, right, sir?
Yes. So that's enough time to read the table. I'll just put this out. এই পার্টটুকু পড়ো and then এই পার্টটুকু সবাই পড়ো, বোঝার চেষ্টা করো এখানে কি বলা আছে। আমি এটা পরে গুছায় দেখাবো, ডোন্ট ওয়ারি। আগে একটু পড়ো, তারপর এই how ionization happens এই জিনিসটা পড়ো। There is a common misconception which was addressed. Yes, সাবির বলো।
Sir, aren't they supposed to damage the cell and kill it? How do they alter the properties of the cells themselves?
I'll explain this in a bit in the process, in the part of the hazard of the radioactivity. It will come in our discussion. Wait a bit.
Okay, sir.
Sure. এই পার্টটা একটু পড়ো, আমি সিস্টেমেটিকলি তোমাদের পড়া যাচ্ছি। I'll answer all of your questions in due time, don't worry.
স্যার নিউক্লিয়ার ফিশন তো এখনো মানে আর্থে এখনো তো হয় না, লাইক আর্টিফিশিয়াল নিউক্লিয়ার ফিশন।
ফিশন শুধুমাত্র আমরা আর্টিফিশিয়ালি করি, ওটা হচ্ছে তোমার নিউক্লিয়ার বম্বের ভেতরে হয় অথবা নিউক্লিয়ার রিঅ্যাক্টরের ভেতরে হয়। Nuclear fission is not a natural process. Fusion is a natural process which happens at the core of the stars. Radioactive decay is a natural process which happens from the unstable nuclei. Nuclear fission is a completely artificial process which we do because we want to do it.
সেদিন বললাম স্যার কি ডেন্স প্লাজমা ফোকাস টেকনোলজিতে এখন নিউক্লিয়ার ফিউশন বলে ক্রিয়েট করবে।
নিউক্লিয়ার ফিউশন ক্রিয়েট করার ট্রাই আমরা অনেকদিন ধরে করতেছি। নিউক্লিয়ার ফিউশন আমি আচ্ছা নিউক্লিয়ার ফিউশন ক্রিয়েট করার পসিবিলিটি নিয়ে আমি একটু পরে আলাপ করতেছি, ডোন্ট ওয়ারি। আগে এই পার্টটুকু একটু পরে, আমি এই পার্টটুকু পড়াই নেই, আর আনসার ইওর কোশ্চেন, ডোন্ট ওয়ারি।
স্যার আপনি কি এই পার্টটা বুঝাবেন না, মানে এই যে
হ্যাঁ,
হাওয়া
তোমরা আগে একবার পড়ে নাও, দুটো প্যারাগ্রাফ একবার পড়ে নাও। I'm watching my mama cats sitting on the heads of their baby cats. This is so adorable. All right, let me explain the ionization part. Kids, listen to me and try to visualize something. One of the common misconception about ionization process. Ionization is what do we necessarily understand by the word ionization? It means the splitting of some orbital electrons out of an atom, by which the atom becomes ion. Or in chemistry, you have also learned that electrons can be absorbed by some atoms, then they can also become ion, which means from neutral state to go into a charged state is what we call ionization. Okay. In the process of radioactivity, one of the common misconception is that, let's say alpha particles are positively charged, so they have +2. So through chemistry, we do understand that they are naturally willing to get 2 electrons from any neighboring source and should try to convert them into helium atom, which is a stable state compared to a basic helium nucleus. And electrons, beta particles, which are basic electrons, they are going to try to get absorbed into other parts as well. So one of the things that kids sometimes believe that alpha particle, whenever they enter into anything, let's say a metal piece sphere or something, a metal piece or something, whenever they'll enter into a metal, they will collide with one of these metal particles and somehow take 2 electrons out of them and become helium atom. In the process, it can make 2 of those metal atoms or particles or medium atoms into ion, because it is stealing 2 electrons. So it's possible those 2 electrons come from at max 2 different atoms, and those 2 atoms are going to become ionized. So in chemistry sense, it might feel like that one alpha particle is capable of do only 2 ionizations, whereas you might also feel like that one electron is one electron, beta particle is one electron. So if it gets hit, if it hits a certain physical object and gets absorbed in it, and getting absorbed in an object essentially means getting absorbed in an atom, because atoms made up everything. So make up everything. So that's why having an ionization using an electron might also mean that an electron comes in and hits into one of the atoms of the object and gets absorbed there, converts into a -1 charge ion, and that's how it might do ionization. So in that process, we might also think that the number of ionization that one beta particle can be able to do is only 1. But this is entirely wrong. What you guys really need to understand that this essentially happens. This happens. It's not that this does not happen. This does happen. But this is a very small part of a much larger story. Let me give you a numerical comparison so that you can make better sense out of it. I'm going to show you some drawing over here to give you a better visualization. Let's say here we have an atom of an object. Here we have an object which is made up with a lot of atoms. Let's say it is made up with a lot of atoms. Okay, and we are going to shoot one alpha particle into this thing. So this alpha particle, let's say, is this dot, which has symbol 2 4. So this has +2 charge, is going to come into this one. Let's try to understand. Do you guys know what ionization energy is? Have you guys come across this term in your chemistry? Ionization energy.
No, sir.
So the energy needed to take the electron from that, right?
Let me give you a small understanding about ionization energy. Ionization energy essentially refers to, I mean, I'm not giving you the exact definition, but I'm trying to transfer the idea to you. Ionization energy is the energy involved in the process of making an atom into an ion. For example, a sodium atom will naturally try to get rid of one atom to get 2-8 on its outer shell layer. So it is very much willing to give out one electron. So sodium into sodium plus happens really easily. So the amount of energy that you might require to provide that, because try to get a hold of this idea. All the electrons, even though it's the outer shell layer electron of a metal, doesn't matter. All the electrons in an atom, they are attracted by the nucleus and they are at a stable state. To achieve the octet on the outer shell layer, they are willing to give out some electron because they want to have the most stable structure on the outermost shell layer. But they're not going to give this out just because you want it. If you keep a sodium atom into a certain location, it's simply not going to radiate out its +1 electrons. I mean, one of its electrons. That's not going to happen. You can only liberate out one electron out of a sodium atom whenever you provide enough energy to that outer shell layer electron so that it can overcome the attraction of the atom / nucleus, more accurately, and can become free of that atom and can travel into something else. For example, if you make a reaction of sodium with chlorine, you can make sodium chloride, which is a salt. So you have to give the outer shell layer electron enough energy to make that transition happen. The amount of energy that you require to feed to electron so that it can become free of the effect or attraction of the atom, it can detach itself from that atom, is what we call ionization energy. Interesting enough, for the group 1 elements, let's say sodium, potassium, cesium, rubidium, those things, they are willing to give up one outer shell electron to get octet in the outer shell layer, which means that these atoms are very willing to give up one outer shell layer electron. But can you make sodium 2+? I mean, have you guys ever come across this idea? Like Na2+?
এটা তো পসিবল না।
Now, আসলে কি পসিবল না?
মানে জীবনে শুনিনি তো।
Possible hote pare, but it must be done under lab conditions because that does not happen naturally.
That does not happen naturally. I mean, the reason it does not happen naturally is this. The idea is very simple, is that try to get the bottom line of this, try to get the basic mechanism. Electrons are attached to the atom by a certain value of attraction force. If you want to make the electron leave from that atom, you have to feed the electron that much energy so that it can free itself. The way the first electron, the outer shell electron, is attached to the sodium atom is very loosely. Let's say just for the sake of making conversation, let's say to make the first electron, the outer shell electron of a sodium atom, which is the 281, the very last one, to make that electron free out of the atom, let's say you need to feed that electron 2 joule, for an example. Whereas if you want to free up any of the electrons on the second shell out of the octet, maybe you would require 100 joule. The difference is massive. In a naturally occurring chemical environment, you cannot provide one single atom 100 joule of energy so that you can actually steal one electron out of that octet. That is not naturally possible to happen. But in artificial environment, you might actually be able to do that. But that's not very common, and that's not very natural. Artificially, onek kishu kora possible. So the difference that lies is in what we call the ionization energy. So sodium has a very low first ionization energy, but it has a very high second ionization energy. But that's not the case for the group 2. Group 2 is made up from, let's say, barium, calcium, strontium, those things, magnesium. They are willing to give up their outer shell layer 2 electrons very easily. Now, what is interesting, let's say you consider a calcium atom. So calcium কত 282 না 2882, সোডিয়াম ম্যাগনেসিয়াম, ক্যালসিয়াম হচ্ছে 2882। আচ্ছা ম্যাগনেসিয়াম ধরো, সোডিয়ামের পরটা হচ্ছে ম্যাগনেসিয়াম। Let's consider a magnesium atom. A magnesium atom has 2 electrons on its outer shell layer. So to get octet, you need to get rid of these 2 electrons. So it is going to be very willing to give out those 2 electrons. So if it so happens that you have a magnesium atom which now has 2H2 electronic configuration on its shells, it will be able, or it will be willing to give up the first electron out of those two pretty easily. Let's say that ionization energy is 2 joule. Let's say the first electron leaving requires 2 joule. Whenever the first electron has left from the magnesium, what is the charge of the magnesium atom? Is it still neutral or has it become positive?
Positive.
Logically, it has definitely become positive, which means now if you want to take out the second electron out of the first shell, you have to overcome a bit more attraction force, because now the entire atom has become more positive than neutral, so it will not be willing to give out that energy by the exact same amount of energy. It will not be willing to give out that second electron, using the same amount of energy. So it is possible, just giving you some values, that the first ionization of magnesium might be 2 joule, and the second ionization energy for magnesium, let's say, might be 2.1 joule. So it's going to take a little bit more energy. I'm just giving 0.1 more. But you cannot make a third ionization of magnesium, because that value might be 100 or 200 joule. To break any electron out of that octet structure, you're going to have to provide extremely high amount of energy, which is not possible. That's why magnesium has a valency of 2. Mg2 plus is very commonly available, whereas Mg3 plus is unheard of. Do I make sense so far?
Yes, sir.
শেলে 2 ইলেকট্রনের মধ্যে ফার্স্ট ইলেকট্রন ব্রেক আউট করতে কম এনার্জি লাগে than the second electron. এটা কেন হয়?
Because the first electron comes out from a neutral atom. Second electron has to come out from a +1 or already +1 charged atom. So the attraction on the second electron would be bigger compared to the attraction on the first electron.
Yes, sir. বুঝেছি.
Okay. And this discussion can made into further aluminum, আমরা boron tone এগুলো নিয়ে একই জিনিস apply করতে পারি. Carbon, the reason carbon never produces an ionic bond is because carbon has 4 electrons to deal with. So it requires a huge amount of energy either to it takes a huge amount of energy either to give out all of these electrons, that usually does not happen, completely give out those electrons, or it takes a huge amount of energy to completely absorb 4 electrons and become C minus. So this is very difficult to happen. That's why carbon never produces ionic bonds. It only prefers to produce covalent bonds. That's just one way to put it. What am I trying to tell you here? What I'm trying to tell you here is that if ionization is to happen, you simply need to provide energy to the outer cellular electron of that substance so that those electrons can come out. That substance doesn't essentially have to be metal. For example, let's say if you consider human skin, what is the human skin made up from? Biological compounds. So we have some protein molecules, because this is flesh. We have some fat molecules. We have some fibrous connecting tissues, stuff like those. So this is a compound molecule which is made up from a lot of stuffs. These electrons and the outer shell layer of this large molecule of the flesh molecules, they will not naturally try or prefer to give out electrons. That's not going to happen normally. But whenever an ionizing radiation, alpha particle, let's say alpha particle, and let's say an alpha particle is being shot from an alpha source, radiative source, and it is traveling towards the human skin and it's about to penetrate the human skin. Let's say, for the sake of discussion, let's put that all the atoms of the human molecule, let's consider they're all identical, just to make conversation, to make this example, make it easier for you to happen. And let's say that the first ionization energy of each of these atom is, let's say, 2 joule. When the alpha particle will be emitted from the radiative nuclei, it might as well start with 10,000 joules of energy, kinetic energy that I'm talking about. Alpha particle will not start with a very minimum amount of energy. It's a pretty heavy particle coming out at a pretty high speed from the process of radiative decay process, and has a huge amount of energy as it is about to hit the human skin. Each atom of human skin requires 2 joule energy to give out 1 electron. Let's say the alpha particle is coming down the path with, let's say, 10,000 joule of energy. So whenever the alpha particle will hit the human skin, it is going to contact with one of the skin atoms, and in the first contact, it will give out 2 joule of its kinetic energy to one of the electrons, and that electron will be liberated out from that atom. It's a pretty fast process. The reason the electron can be liberated out, because like I said, that to make electrons liberate out of an atom, all that you need to do is to give it energy. If the electron can have enough energy, they will be free from the effect of that atom. That's the basic process of ionization. So let's say the alpha particle is about to hit the skin. It hits the one atom on the skin. In the first hitting, 2 joule of the alpha particle's kinetic energy will be shared to one electron, and that electron will be spit out from one of the skin atoms, and that atom would become one ion. That is the first ionization. How much energy did the alpha particle lose? 2 joule. How much did it start with? 10,000. So how much is remaining? 9,998 joule. Right?
Yes, sir.
So as the alpha particle will travel through the skin, just do by basic mathematics, altogether how much energy can it spend? So that it can spend 10,000 joule of kinetic energy. That's what it started with, and it is hitting, and it needs to spend 2 joule for every ionization of the human skin atom. So altogether, basic mathematics tells us that that alpha particle, before coming to stop, that alpha particle should be able to do 5,000 ionization. Correct or wrong?
Yes, sir. Correct.
Yes, sir.
Yes, sir. So it is gonna be able to do 5,000 ionization, not by its chemical bonding, not by stealing electron from out of the skin atoms, because it is +2 charge. It is happening mostly due to its kinetic energy sharing. Once the alpha particle come to a stop point on inside the skin, it will then, because of its chemical property, once again strip out 2 electrons out of the neighboring atoms and make itself into a helium atom. So mathematically speaking, if an alpha particle starts with 10,000 joule of energy, where it spends 2 joule energy for each ionization, it will be able to do altogether 5,000 ionization by its kinetic energy spending. And at the end of that journey, it should be able to do 2 more, because it's going to steal 2 more electrons to make itself into a helium atom. So altogether, it can do how many ionizations?
5,002.
5,002. So that's the point that I want all of you to understand, that chemical process of that alpha particle will absorb 2 electrons and make itself into a helium atom does happen. It's not essentially obliterated, or it's not discarded from the scenario. But that too is a really small number compared to the 5,002, right? So the most ionization does not happen because of its chemical property. Most ionization happen because of its high kinetic energy amount. This is the ionization process. That as the particle penetrates through a physical medium, that might be a gas medium, liquid medium, solid medium, flesh medium, whatever medium, as it collides with the medium particles, atoms more precisely, it shares a portion of its energy, kinetic energy, to those medium particles or atoms outer shell layer electron, and those electrons leave out from their atoms, making it one ionization, and which slows that ionizing particle. That our particle can also be a beta particle, it can be also a gamma particle, but gamma particle is too different. Gamma particle, so that can be a beta particle as well. So they're going to share a portion of their alpha particle kinetic energy, and they're going to slow down a little bit. This is how ionization happens, not because of the chemical virtue. Chemical virtue does play a role, but that's a very small part of a very large count. Could I give you a concept of what is the ionization is all about?
Yes,
sir. এই প্যারাগ্রাফ, এই ফার্স্ট প্যারাগ্রাফটা আরেকবার পড়ো।
So, sir, as the alpha particle will pass through the substance or the medium, it will slowly turn into helium gas.
It will not, I mean, I wouldn't say it will slowly turn into helium gas. I mean, that might actually bring about the idea of a morphing kind of state, like jeta morphing into helium. No, it slows down, and eventually at the end of its journey, it becomes a helium atom. That conversion happens at the end of the journey, not over the journey.
At the end of the reaction, there will be just helium gas.
Helium atom.
Yeah.
But if I have to say it becomes a helium gas, I need to talk about a significantly large number of helium atoms available, because that's what defined by gas, a large amount of helium atoms. So it's better to say helium atom.
Yes, sir.
Yes, Fardin, follow.
Sir, with the help of ionization, can we make an element behave exactly like another element?
Yes. We don't even need to take help from ionization. This is also already present in our periodic table. lanthanides and actinides আছে না
Yes, sir.
যেগুলো periodic table এর নিচে দেওয়া আছে
Yes, sir.
all of those lanthanide series elements and all of the actinide series elements have such an electronic configuration that their outer shell layers are exactly identical. So all of their chemical reactions are exactly identical. The only difference they have is in their proton number and relevant isotopic neutron number or mass number. All the lanthanums and all the actinides, they work. Lanthanides and actinides, lanthanum to metal এর নাম, গ্রুপটার নাম ছিল lanthanides. All the lanthanides and all the actinides are similar. I mean, all the lanthanides are similar, and then all the actinides are similar. They are not similar across each other, but they are similar within that horizontal line, chemical behavior. So we don't essentially have to do artificial behavior. We already have that available. So answer to your question to Fardin is yes.
Oh, okay.
এই ফার্স্ট প্যারাগ্রাফটা কি প্রপারলি মেক সেন্স করতেছে সবার কাছে?
Yes, sir.
Yes, sir.
আমি এটা বুঝি না যে the radiations are not radioactive. The unstable nuclei where they came from are radioactive.
Okay, I'll explain this. Let's say I'm about to vomit. Why? Because I'm sick. I feel sick. If I vomit out, vomit will come out of it. Is the vomit sick or is I'm sick?
You're sick.
Vomit is the
Vomit.
dart. Vomit is the garbage which I cannot put into other people or in unlikely places. All right. So radioactive elements have the capability to emit out alpha, beta, or gamma. Those are the ionizing radiation. The radioactive atoms are not ionizing radiation. They produce ionizing radiation. For like the example, I can make vomit. বুঝা গেছে?
Yes, the radioactive material can produce radiation. Radiation cannot produce radiation.
Exactly. Radiation can produce ionization.
But ionization cannot produce radiation.
No. Yes. No. So that's the part. So one of the other idea that I'd like to discuss is that about the penetratability of these three different substances. I said that I'm going to discuss gamma rays differently. There's a reason for this. Gamma, the entire idea of the dual property of light, which is that light can sometimes behave as wave, light can also sometimes behave as a particle, is not essentially covered very largely in your O-level syllabus, not even in your AS syllabus. It comes in your A2 syllabus. But the thing is, I mean, I am telling you this to make sense with you. Not a part of your syllabus though. সেটা হচ্ছে যে light, if you observe different behavior of a light, they are gonna behave differently. I mean, it's very difficult for me to actually logically make sense, but if I give you an example, it might make sense. For example, when I am in the classroom, I'm a teacher. When I am eating, I'm an eater. Let's say when I'm fishing, I'm a fisherman. And blah, blah, blah. I'm the same thing, but looking at what I'm doing at a certain point of time, I can be different things. Light behaves that way. Does it anyhow make sense?
Yes, sir, it
Yeah.
does.
Yes, sir.
Yeah, Ryan, you have a question?
জি স্যার স্যার আয়নাইজেশন আমরা তো বলতে পারি না যে এনার্জি কনভার্সন হয় কারণ ইট স্টেজ ইন কাইনেটিক এনার্জি রাইট থ্রুআউট দ্য আয়নাইজেশন প্রসেস
Energy conversion hoito. I mean, we are making the slowing down of the ionizing part radiation, which is causing the ionization of the medium particle which it is penetrating. So we can say that ionization would actually give rise to a potential energy, chemical potential energy. So I can say yes, there is a bit of a conversion. The kinetic energy from the alpha particle, let's say using the example of alpha particle, the kinetic energy of the alpha particle converts into potential energy between the ion and the electron which has been emitted. So between them there will be a potential energy developed, and the electron which is produced, it is going to leave from that atom at a pretty high speed. It's going to be shooting itself out. So that emitted electron would also have some energy.
ইয়েস স্যার
Potential energy কোথায় convert হয়, sir? The electron which is inside the atom.
No, the electron
Energy.
which is about to leave from the atom or which does leave from the atom. Because try to think about it. Whenever the electron is made free from the atom and it is leaving away from that positive ion, leaving the positive ion behind, they themselves are oppositely charged. And as the distance between those two oppositely charged particles increase, they basically work against the inherent attraction between themselves, pretty much like the idea of GP. If you take an object further away from the Earth, you increase the GP because you're working against the gravitational force. In the same way, if you are taking that electron away from the positively charged remaining ion, you have to increase the in between potential energy, which is electrostatic potential energy.
Which is electrostatic potential energy. So the kinetic energy of the alpha particle converts into electrostatic potential energy as the electron leaves the atom, right?
And also a part is also converted into the electron's kinetic energy because it leaves with some speed.
Yes, sir. And sir, arekta point, gravitation, মানে electrostatic potential energy যেভাবে বাড়তে থাকে, the attraction between those two charged particles reduce. Therefore, electron speed to আস্তে আস্তে বাড়তে থাকে. So আমরা এটা বলতে পারি না যে kinetic energy increases. GP.
Electron speed বাড়তে থাকে না. Electron speed টা কমতে থাকে. Let's say the electron was liberated from that. Let's say from that 2 joule of energy, electron was liberated using 2 joule, and it's going to have some very small amount of kinetic energy by which it will start the journey away from the remaining positive ion. So as it goes further, the force will decrease, but the speed will also decrease because the pull will be always working towards that positive ion. So it's the same thing that if you shoot a rocket at a pretty high speed from the ground, as it goes up, it does not speed up. It essentially does what?
Slows down.
That's what happens. It gets further, but it slows down.
So its speed reduces at a reducing rate.
Yeah, exactly. I'd put it that way. Perfect. Ryan, did I answer your question?
Yes, sir.
Okay, drop your hand. I appreciate that.
Electrostatic potential energy
the two oppositely charged particles, the electron from the outer shell layer and the remaining positive charge ion, they are being separated from each other. So you are working against a built-in force of attraction between two opposite charges. That's electrostatic force. And whenever you work against that force or separating two particles out, that produces electrostatic potential energy.
Thank you.
Sure. So the other thing that I was trying to tell you is about gamma rays is that for the time being, let's consider gamma photons are particles which have momentum, but they don't have any rest mass. They are basically a lump of energy or a packet of energy. For the time being, consider that so that I can define them as a particle. So gamma photon can be considered as gamma particle, or they can be also said to be electromagnetic waves. For the time being, let's consider them as particles. So gamma photons or gamma particles. Gamma particles themselves are energy. They are not going to give out energy. Alpha particles is an actual mass which has energy within itself, whereas the gamma photon is energy. Now you might wonder, how does that work? I mean, how does gamma photon being only energy moves around? I mean, energy has to be inside something. That's the beauty of gamma photon, which I'm not being able to describe in detail for your level. It's not applicable. So believe my words, gamma photon is the energy. I mean, one weird way I can make this example is that let's say mango is sweet. So mango has sweetness in it. Now let's say I tell you that, well, I don't need the mango. Here is the sweetness of the mango, and I give you that. That would be weird, right? That would be really weird, right? Like taking out a property out of a mango and telling you that this is the property of that mango that I can give you without the presence of the mango. We don't need that. Gamma photon is something like that. That it is raw energy form without the presence of any carrier, any mass, that is. It has some momentum of its own, but that's a different story relevant to relativity. So I'm not getting into that idea. You can ask me questions, but I'll be always telling you this. I'm not getting into that idea. I'm not getting into that idea because I really cannot get into this idea for your subject level. So gamma photons, they do not essentially do ionization in the same way that this is mentioned over here. What the gamma photons do, gamma photons themselves are energy. So one gamma photon can practically do one ionization. If whenever a gamma photon is penetrating through a physical medium, if that gamma photon splashes onto one of the outer cellular electrons of atom, that electron, exclusively that electron, receives all the energy of the gamma photon in a single go. It's like winning a lottery, not getting a salary. Do you get the difference between winning a lottery and salary?
না স্যার এটা বুঝি নাই এই এক্সাম্পলটা
Getting a
Not
salary
really
means
very
that you are getting a fixed amount of small money every month. So you don't become rich overnight. Winning a lottery means you become rich overnight. So what I'm trying to tell you is that whenever the gamma photon crashes onto one of the outer cellular electron, it receives all of the energy of the gamma photon immediately, like winning a lottery. It does not happen by single steps. It happens immediately by the transfer of the total energy, and that one single atom will produce one ionization. So gamma photons, gamma photons will get absorbed in the material, and they will do ionization by the process of absorption. But this is going to be really happening at a very low rate. Why low rate? That's where the idea of penetration capability comes in. I'm going to talk about penetration capability in a bit. Taking a small pause, I need to use the washroom. What is atom mostly?
Empty space.
Empty space.
Empty space. Beautiful. So I want you kids to visualize, let's say, for example, it's not actually scalable, but try to visualize a solar system. Let's say you visualize a solar system. Solar system is also mostly empty space. There is a central sun, which is unlike nucleus, because nucleus is actually very small and massive, but sun is not that small with respect to the size of the solar system. Is actually quite large. But let's assume that a solar system. Now think about it. If you have multiple atoms neighboring side by side for a solid object, practically speaking, it's mostly empty space. Now try to think about it. You have lines of atoms which are stacking onto each other, making a layer of atoms. Try to visualize a layer of atoms. Can you do that? Layer. Then now try to add more layers one onto another to give you a three-dimensional spacing of the atoms. Can you visualize that?
Yes, sir.
Okay, sir. Let's consider this is a solid object. It just so happens that the size of an alpha particle is big enough that it cannot penetrate through a significant number of these layers. For a solid object, an alpha particle is that much big. I mean, I'm not giving you numbers, but I want you to appreciate this. The alpha particle is that much big that it will be stopped by, let's say, maybe 10-15 layers of those atoms. 10-15 of layer of these atoms means something like this. I mean, another way I can put it this way. Let's say if you have a strainer. Do you guys know what a strainer is?
No, sir.
Sir.
Strainer hoche chakni.
Oh, yes, sir.
Okay. Let's say let's say you have a strainer, and consider that strainer as a metal mesh, which represents one layer of atom. If you add up multiple strainers, one strainer net, one after another, stack these up. Okay. So you're gonna get a pretty dense structure, right? Like a really dense structure. Like one strainer net and then another one, then another one. Let's say you have stacked up 10 layers of strainer nets. Now, if you shoot, let's say through this strainer net, if you shoot really small particles, it is possible that through the gaps of this thing, alpha particles can actually pass through. I still can make sense with you. Can I? No, I cannot. Actually, let me try it in a different way. Alpha particles are big enough that they will be absorbed, or as they will pass through the layers of the physical medium, they are likely to hit some of the atoms pretty often. Or in other words, I can say, whenever the alpha particle will actually enter into a physical body, they will lose their kinetic energy within a very short amount of time, because they are so big. They will really frequently make their energy loss. or as a large alpha particle enters into a solid object, for example, it will make contact with the neighboring atoms outer shell layer electrons really often, because the size of the alpha particle is big, so that collisions are going to be really frequent. Frequent is the word, yeah, that's what I was looking in my head. That collisions are going to be pretty frequent, and it's going to lose its energy over a small distance. So the actual thickness that an alpha particle can actually penetrate into an object is not going to be that much, because all of its available energy will be spent up over a small amount of penetration. Contrary, if you consider for a beta particle, which is an electron, that is quite small, I mean like too small compared to an alpha particle. Whenever the electron will pass through a solid object, because atom is mostly empty space, these electrons can actually cruise through a series of atoms without even colliding. Let's say, think about that, let's say an alien spaceship passing through the solar system without we even knowing about it, because it is small. But if you want to pass, let's say, sun-like stars through our solar system, it is quite likely that it will collide with some of the nuclei, some of the sun, right? Because sun is quite big.
Yes, sir. Yes, sir. Yes, sir.
Or what will these alpha particles hit again?
These alpha particles will hit the electrons of the outer shell layer of the medium atoms. So মনে করো মিডিয়ামে মানে মনে করো মিডিয়ামে অ্যাটম গুলো একটা পর একটা স্ট্যাক করা আছে লাইক বলের মতো, ঠিক আছে? আলফা পার্টিকেল যখন তার ভিতর দিয়ে যাবে, ওই আলফা পার্টিকেলের সাথে সাইড বাই সাইড মিডিয়াম অ্যাটমের ইলেকট্রন গুলো ইন্টারাকশন হবে খুব ফ্রিকোয়েন্টলি, বিকজ আলফা পার্টিকেল ইজ কোয়াইট বিগ, সো ইটস গোনা বি লুজিং দি এনার্জি টু দেম রিয়েলি অফেন. So it's gonna be losing its total kinetic energy over a very small distance by giving out those energies really, really fast.
But so that medium is supposed to have is supposed to be made of all those atoms. So ভিড়তে এমনিও হবে অমনিও হবে. Like is it just alpha?
আচ্ছা, আমি তাহলে অন্য একটা ডিফারেন্ট এক্সাম্পল দিই. মনে করো, আচ্ছা আমি ডিফারেন্ট এক্সাম্পল দিই. Consider different example. Let's say in a stadium, we are making an assembly of school kids. So let's say the school kids are all standing, let's say 5 feet apart from each other. 5 feet is about the more or less about the height of a kid. They're all standing 5 feet apart from each other, and they are standing both of their toes touching each other, which means they are not spreading out or they are not moving. They're just standing vertically. Now, if a person is asked to shoot a football through these kids from one end of the stadium to the other end of the stadium through the kids, is it going to be likely possible?
No, sir.
No.
After traveling a little bit, it's going to hit to a lot of kids and it's going to become stopped, right?
Yes, sir.
Yeah, this is a better example. So this is what happens to alpha particle. But if you try to shoot a tennis ball, maybe it's going to be pretty easy. I mean, you can have a tennis ball and you can somehow find a trajectory and you can shoot it to a very long distance down the path of the kids till it does not make any contact with any of the kids. But maybe you wouldn't be able to avoid all the kids, but you would be able to go further deep into the kids if you use a tennis ball. Am I correct?
Yes, sir.
Yes, sir.
On the third example, if you want to shoot a sniper rifle bullet with a scope and everything, it is possible that you can shoot a bullet with appropriate aiming and positioning, a bullet without touching any of the kids. This is the basic comparison of what happens between an alpha particle, a beta particle, and a gamma particle. Alpha particles being large, hits too often, stops pretty early. Beta particles being small, hits less often, and have more penetrating power. Gamma photons being extremely small, almost does no hitting, and can penetrate through most of the objects unaffected.
Sir, I have a question.
But acha, before I take the question, এই এক্সাম্পলটা কি বুঝা গেছে?
Yes, sir.
মানে এটা ভিজুয়ালাইজ করতে পারছো সবাই?
Yes. Sir, একটা জিনিস ছিল।
দাঁড়াও, তোমার আগে আরেকজনটা কি জন্য কোশ্চেন করতে চাইছিল?
আমি স্যার।
হ্যাঁ বলো।
স্যার আপনি বলেছেন গামা ফোটন স্যার এনার্জি, সো যেরকম অ্যালফা পার্টিকেলসের বেলায় ইলেকট্রনসটা অ্যালফা পার্টিকেলে চলে যায়, সো গামা ফোটনসে তো ইলেকট্রনটা এনার্জি অ্যাবজর্ব করার পর এটা তো যখন ব্রেকআউট করবে ইলেকট্রন সেল থেকে এটা কই যাবে?
Oh, that electron will be shot away from that atom. So that atom will become positively charged, and that electron will start to travel in random direction. It will have much smaller energy than a beta particle, but it can get absorbed to any of the neighboring particles, let's say a couple of centimeter away, and convert that into a negative ion, or that electron might altogether be get out of the object. That electron can have different fates depending upon in which direction it is emitted and how far deep into the object it was created from. But the remaining thing will essentially become a positive ion. That's a given. That's a definitive fate.
Yes, sir. বুঝছি স্যার।
তাকি আছে বলো।
জি স্যার, ওয়েট স্যার, হ্যাঁ স্যার, এই যে যেরকম আপনি তো বলছেন স্যার যদি টাচ না লাগে স্যার ওটা সাইবারপুরা ভিতরে চলে সবার মাঝখানে চলে যেতে পারবে স্যার, কিন্তু স্যার যদি টাচ লাগে স্যার কারোর সাথে দুর্ভাগ্যবশত স্যার, তাহলে স্যার ওটা কি স্টপ হয়ে যাবে না, কারণ ওটা এনার্জি ম্যাগনেটিক অনেক কম।
এক্স্যাক্টলি, আমি ওই জিনিসটা তো বলছিলাম যে গামা ফোটন যে একটা সার্টেন অবজেক্টের মধ্যে দিয়ে ট্রাভেল করার সময় যে আদতেও কারোর সাথে হিট করবে তার কোনো গ্যারান্টি নাই। হিট না করার প্রবাবিলিটি বেশি, বিকজ গামা ফোটনস আর এক্সট্রিমলি স্মল, বিকজ অ্যাটম ইজ মোস্টলি এমটি স্পেস। বাট যদি বাই চান্স ইফ ইট অ্যাকচুয়ালি হিটস ওয়ান অফ দ্য particles, all of that gamma photon energy will be transferred to that electron immediately. বুঝা গেছে? That's why I said that one gamma photon.
Does the gamma photons have a large amount of energy?
That's why I say that one gamma photon can make one ionization, unlike alpha or beta. One alpha particle can do a lot of ionization. One beta particle can also do quite a good number of ionization, but that is much less than alpha particles, because gamma photons, because beta particles are essentially electrons. Their energy content is not as big as alpha particles, because alpha particles are pretty massive. I mean, kinetic energy comes from what? Half mv square, right? So if you have a pretty large mass and they're all coming from radiative decay, so in measurement, what the scientists found out that alpha particles does contain a much bigger amount of energy compared to the beta particles. So the beta particles can do much less amount of ionization, but then again, because they can penetrate further, that ionization will be spaced out. The concentration of the positive ions would not be accumulated in a single space. It would be really spaced out over a long length of flesh or over a long depth of the object. Unlike alpha particle will do all of the ionization, which is a pretty big number of ionization, within a small space, and which should be very concentrated.
মানে স্যার ওদের র্যামিং পাওয়ার বেশি থাকে, ওরা র্যাম করতে পারে অনেক।
That's the whole point. Yeah, exactly. That's what we used over here. Punch. Yes, yeah, Sabi বলতেছিলা।
Sorry, sir.
তুমি কি সেটা বলতে নিছিলা মাঝখানে? I went over your speech because I really wanted to finish till this point. Yeah, তুমি কি সেটা বলতে নিছিলা মাঝখানে?
না sir, sorry.
আচ্ছা, সমস্যা নেই, বুঝা গেছে। Okay, fine, good. So this is the basic idea of ionization, and this is the basic idea of penetration power. Now comes to the part that why is that, I mean, in terms of hazard, you can see over here, I mean, what is the hazard? Okay, we did not write hazard over here. But in terms of hazard, alpha radiations are the most hazardous, beta particles are less hazardous, gamma particles are the least hazardous. But make no mistake, they're all hazardous. I mean, don't think that being in a gamma radiation environment is healthy. No. Being in any existing in any radiative environment as a living organism is bad. Being in an alpha particle environment is most bad. Being in a beta particle environment is less bad.
Very bad, but less bad compared to alpha particle.
Exactly, and being a gamma particle is the least bad, but they're all bad. So don't get the wrong idea that that gamma particles are good. No, they're all bad. Okay. So one of the things that I want to understand that Sabir or Abdullah, I forgot. One of you kids asked this question. Ryan, I'll take. Okay, Ryan, go ahead. Ask your question.
No, sir, you can finish. I'll ask it later.
I appreciate this. So one of the things that you kids asked me that how is it that shouldn't the ionizing radiation actually practically destroy the cells? I mean, why does the idea of this cancer and tumor growth comes in? Now, here is the deal. This is the part that I really want you to understand. All the parts that I'm about to tell you right now, I'm going to covering quite a bit about immune system and physiology of living organisms. But you will not need all of this. But I really want you to understand and visualize this. Okay. Try to understand. Beta particles do their ionization over a pretty long distance. Alpha particles concentrate their ionization over a small distance. So here is the deal. If an alpha particle hits the skin of a human being, it might as well penetrate, let's say, 2-3 millimeter, at max 5 millimeter. Like extremely high energy alpha particle would be able to penetrate only up to, let's say, 5 millimeters. But within this 5 millimeter thickness of skin, or maybe within this 2 or 3 millimeter thickness of skin, it might as well do millions of ionization. Interesting information. It can do millions of ionization. Every cell of a living organism is designed to survive till its useful life, which means if you damage a cell, it will try to repair itself. In this process, certain cells could have their cytoplasm damage, certain cells could have their cell membrane damage, certain cells could have their Golgi bodies, endoplasmic reticulum, those things damaged, mitochondria damage. Certain cells can also have their nucleus, or to be more precise, the genetic code, which is the sequence of the bihelical strand of the DNA, that might get damaged. Different cells can have different part of their chemical construction damaged. Cells which cannot reconstruct them after they are damaged, they're gonna be dead, and our body system will remove them. Problem happens due to alpha particles because the concentration is so dense that in many cases, or let's say in most cases, it so happens that there exist some body cells which have their genetic code somehow got flipped. Now, what do I mean by this? Try to understand this. How does the two helix of the DNA strand are bonded together? With hydrogen bonds, right? Do you guys know what I'm talking about?
Yes, sir. Yes, sir. It's a double or.
For those of you who don't know what I'm talking about, believe my word. The DNA, basic DNA, it has two strands, like a ladder, like a two-stage ladder, which we call it helical. It is made up of two strands which are connected with each other by some hydrogen bonds. They can be double bonds or they can be triple bonds, depending on the which protein molecule that we're talking about. Now, interesting information is that the sequence in which these proteins are arranged is basically what our genetic code is all about. Whether a person is going to be tall, short, black, white, smiling always, not smiling always, muscular or robust, or good immunity or less immunity, intelligent or dumb. All of these things are basically coded in our genetic system. So how does the immune system work? Let me bring that up in this part. The way our immune system working in this case means that it works as our safeguard, which is like an antivirus system, basically our body's antivirus system. Is that whenever an external organism enters into our body, the immune system particles, for example, white blood cells mostly, there are many different names of those things. I don't know all their names. They get close to those things, check their own DNA code with those things in DNA code, and see if that match. If it does match, they leave them alone. They deem them as part of the body, that's why our immune system does not eat up our own body. But if that does not match, then the immune system cells kill those cells. That's where the antibiotics come in, and that's how the immune system works. That's how they kill the germs, and that's how we eventually can become healthy again once we have become sick. That's
the matching অংশটা কোনটা কি ম্যাচ করে?
The immune system cells or the white blood cells match their own genetic code with the external particle. For example, it's a bacteria's genetic code. They do it somehow, and if those things do not match, they destroy that cell. If these things do match, they do not destroy that cell. Matching means they belong to us. Non-matching means they don't belong to us. Kill it.
Yes, sir.
This is a very robust description of how the immune system works. There are many nooks and crannies of this whole description, but this is a very robust version of how the immune system works. Why am I telling you this? This is the problem that happens. Let's say some ionizing radiation, might be alpha, might be gamma, might be beta. Some ionizing radiation got into the body, and did some change in the genetic material in those strands. So let's say there are 200 million of those sequence, and some radiation parts changed only 12 or 20 of those positions. Now, changing this position means what? It will actually break down that strand at certain point. Naturally, the cell will try to repair that, but in the process of repairing it, it might flip those positions because they are basic protein molecules. So you will have a cell that exists in your body, which in its genetic code does have, out of 20 million sequence, everything is similar except for 10 or 12 sequences are slightly different. Try to understand. So you have a different genetic code cell in your body because of the ionizing radiation. This is the start point of a tumor. This might convert into a tumor, this might not. What happens whenever the WBCs come and they keeps on checking this thing, they will see that, well, this one matches with us, let's move on. If they cannot detect that anomaly, they will allow that cell to live on. But if they can detect that anomaly, they will kill that cell. In our body, by means of natural radioactivity, a lot of these cells are having this genetic code change every single second. That's one simple part of mutation. I mean, whenever a certain living organism has their genetic code changed, that's what we call mutation. So we're having a lot of these things happening within our body. Our immune system is smart enough and effective enough to kill all of these automatically. So that's why we are not converting into Hulk overnight. At least not any of us are converting into Hulk overnight, because our immune system is taking care of us. It can handle with a certain amount of mismatching. Whenever the ionizing radiation happens to a certain part of the body, whenever multiple different cells or there is a much more incident of mismatch, then the immune system starts to overlook those particles or those genetic codes and allow those cells to live on. That's what the problem gets started. You see, these mutated cells do not have the exact same genetic code as the body's other cells, but they do have almost the same genetic code. This is usually not a problem. This will usually not be a problem if that part of the genome is within our within our একটা আছে হচ্ছে তোমার প্রকট বৈশিষ্ট্য, একটা হচ্ছে প্রচ্ছন্ন বৈশিষ্ট্য। না হ্যাঁ ডমিনেন্ট, হ্যাঁ একটা হচ্ছে ডমিনেন্ট জিন আর একটা হচ্ছে ডরমেন্ট জিন। ফর এক্সাম্পল blue eyes are dormant genes, very rare, but brown or black eyes are dominant genes. কোকড়া মাথার চুল is a dominant gene, whereas lustrous hair is a dormant gene.
Recessive
gene. Recessive অবশ্য অন্য একটা মিনিং হয়। Anyway, dormant and dominant এই দুটো ওয়ার্ড ইউজ করি। If this part of those genetic combination it belongs to the dormant gene part, that's not a big deal. This is not going to exhibit as a much bigger at all. But whenever this one comes to a dominant part, that actually gives more trouble. The most problem that happens, I mean, where the cancer part comes in, is that if any of those changes of those genetic code affects the mechanism or the command that those DNA strands produce for the indication of cell multiplication. সেল মাইটোসিস আমি বুঝাচ্ছি। মনে করো একটা সেল মাইটোসিস হয়ে ডিভাইড হয়। তো বলো তোমার সঙ্গে মাইটোসিস বুঝো?
Yes sir.
Yes sir.
মাইটোসিস কে বুঝো না? একটু আওয়াজ দাও বা লিখো। মাইটোসিস কে বুঝো না? Either respond or write in the group chat. It's okay. If you don't understand, I'll explain it better. But if all of you understand, I'll not take that time. Okay. Mitosis is the basic division process of body cells replicating itself automatically. Basically, the way one body cell photocopies itself into a second body cell and divides it into a second body cell is what we call mitosis. The basic way of us growing up. So, to make the mitosis happen, to make the mitosis happen, the cell has to do a lot of things. It has to make the cell to make one body cell make a exact copy of its own self. It has to achieve a lot of things. It has to create mitochondria, it has to create Golgi bodies, you have to make itself bigger, and you have to achieve all of those nutrients from the outside. And once it is big enough and it decides that fine, now I can divide into two pieces, then it is going to undergo mitosis process. There'll be and then it will make into a new cell. Now, so that my point being that before all of these things, before a cell can divide into two parts, it has to do a lot of stuffs. Now, the cell has the genetic strands or the bihelical bonds, they have a certain way of working that beyond a certain point of growth, they gives the command to the cell that you can now multiply, you can now divide, and it will get into the division portion. In other words, I can tell you that for a cell, that genetic code is basically the brain that commands all the parts of the cell so that it can do their job. All of the parts of the cell can do their jobs. Problem happens, I mean, the way tumors can grow whenever one of these ionizing radiation messes up with this multiplicative part of the genes. It's not very common. That's why a lot of people are not dying from cancer, but more people are dying from cancer because of another reason, which I'm going to address in a bit. But whenever this multiplication part of the gene, that part gets hampered, or that part becomes convoluted or somewhat changed, and the cell's immune system does not kill that thing, that changed genome code will start to multiply more often than usual. Try to think about it. What is a tumor? It is an excessive growth of cells which produces a lump in your body. Basic idea. শরীরে কোনো জায়গাতে টিউমার হওয়া মানে কি ওই জায়গাতে যতটুকু সেল ডিভিশন হওয়ার কথা ছিল তার থেকে বেশি সেল ডিভিশন হচ্ছে, ফলে ওই জায়গাটা এখন ফুলে গেছে। ফুলে যাওয়ার ওই গোল্লা জিনিসটাকে আমরা কি বলতেছি? টিউমার বলতেছি, রাইট? So whenever this multiplication part of the genome code gets affected and body's immune system cannot kill those cells because their genetic codes are mostly matching, it overlooks those cells, they start to absorb nutrients pretty fast and they start to multiply themselves really, really fast. This is the growth of a tumor. If these cells are somehow connected to the blood vessels, it is very much possible that some of these cells might get disconnected from this actual tumor and enter into the blood vessel. And if something enters to the blood vessel, to be honest, this tumor cell can find its destination to any part of the body. Heart, lungs, brain, you tell me. It might get transported to any part of the body, get stuck in a different place, and start producing another tumor over there. Whenever the tumor becomes spreading, that's what we call a cancer. এই পর্যন্ত বুঝা গেছে কিনা? কোনো কোশ্চেন থাকলে আমাকে 11 কোশ্চেন করো, one by one. Raise hands. Okay, Sabir বলো, you apparently is the only person. বলো
স্যার, ডিএনএ তে যে হাইড্রোজেন বন্ড দিয়ে বানানো জিনিসপত্র যেগুলো আছে না, সেগুলো ধরেন ড্যামেজ হলো, তারপরে যে the body will naturally try to repair it, যেটা করতে গিয়ে কিছু একটা ফ্লিপ হয়, এই ফ্লিপিং জিনিসটা বুঝি নাই।
সেটা হচ্ছে যে মনে করো তোমার এটিসিজি তো হচ্ছে আমাদের 4টা প্রোটিন না এগুলো? প্রোটিন না
স্যার?
Nitrogenous bases, sir.
Nitrogenous bases, sir.
So they're not protein.
Sir, protein, nitrogen.
Are they protein? I think they are protein. They are.
Nitrogenous.
Aren't they amino acids?
Amino acids. Nah.
Bases, sorry, not protein, bases. Okay. These bases are ordered in a specific pattern. Now, let's say মনে করো আমাদের অনেক বড় একটা প্যাটার্ন আছে, আমি এখানে এঁকে দেখাচ্ছি তোমাকে to make a bit sense with you. I'm not sure how much I can make sense because I'm not a biology teacher, but I hope to be able to. মনে করো এটা হচ্ছে আমার একটা স্ট্র্যান্ড, ঠিক আছে? আর মনে করো এটা হচ্ছে আমার আরেকটা স্ট্র্যান্ড। ওকে, সো মনে করো এইখানে এই জায়গাটুকু তো মনে করো আমার এখানে অল্প একটু জায়গা ভেঙে গেছে, ভেঙে এই জিনিসটা এখন কয়েক টুকরা হয়ে গেছে, এখন আমার এই জিনিসটা এখন এখানে 3-4 টুকরা হয়ে এখানে ভাসতেছে, ঠিক আছে? মনে করো এখন এই পার্টের উপরে আছে এ, এই পার্টের উপরে আছে এ, এই পার্টের নিচে আছে হচ্ছে সি, এই পার্টের নিচে আছে সি, লেটস সে, ঠিক আছে? এখন ন্যাচারালি কি হওয়া উচিত ছিল, এটা এখানে যাওয়ার কথা ছিল, তার নিচে এটা যাওয়ার কথা ছিল। যদি আমি এই পার্টটাকে উপরে বসায় দিই, আবার এই পার্টটাকে নিচে বসায় দেই, আমার কন্টিনিউয়াম কিন্তু বিল্ড আপ করবে, বাট দ্য সিকোয়েন্স উইল বিকাম স্লাইটলি ফ্লিপড।
And this is the alteration, and since it is so little, the immune system detective system may not even recognize it.
Exactly, and this is what we call a mutated cell, where the genetic code has somewhat got convoluted or defective compared to the other healthy cells.
And if these cells are stuck in a particular part of the body, we do not call it cancer, we call it tumor. But if it gets mobile and starts traveling to different parts by different processes of the body, that's the cancer.
Exactly.
And this is caused when the ionizing radiation messes with the DNA cell multiplication protocol instruction, whichever.
Exactly. Those commanding parts.
So radiation does what we think. It damages, but very small parts of small cells.
Exactly.
Anything. Probabilities, jeta hoy.
Exactly. Probabilistically, it is very small. That's why we don't have a lot of tumor cells growing in our body. Natural radioactivity does give birth to, can give us some tumor cell, but which our immune system can handle with it. Or the concentration of those cells are not so high that our body doesn't even feel it. But there is a reason that why we are having so many increasing number of cancer patients over for the last decades or for the last 2-3 years compared to earlier human history. There's a reason for this, which I'm going to address in a bit. But yes, up to this point, everything that you've said is exactly what I meant.
Yes, sir. Understood.
Okay, Ryan, bolo.
So can you repeat the part where you said that how the tumor was formed? A lump of cells টা কিভাবে form হচ্ছিল?
Lump of cell টা form হচ্ছে যে the multiplication protocol of the genetic code, or that commanding part of the genome helix, if that part gets somehow overactivated, or which means that, let's say a cell is supposed to divide, a human cell, let's say just for the sake of making conversation, let's say for a human cell is supposed to get undergo mitosis every 7 days, let's say. Okay, now if it somehow gets messed up, that it gets a command that it's going to start multiplying after every 2 days, so it's going to absorb more nutrient out of your blood and develop a division process of 2 days. So there are going to be more of these cells within a small part of your body, which exposes itself as a lump/tumor. The multiplication process becomes faster, bottom line.
Yes, sir. But sir, there's also a chance that the opposite could also occur, right? 7 days,
yes.
Let's say 14 days হয়ে যেতে পারে because of the alteration of the DNA.
Yes, হতে পারে. For example, one of this type of opposite type of thing is one of the part of opposite type of thing. Taki gunun করে না. One of the opposite part that can happen is what is essentially the reason of blood cancer. The most common type of leukemia or blood cancer is that the bone marrows cannot produce properly working RBCs or red blood cells. Okay, so what actually happens? The bone marrows are supposed to produce red blood cells, which are supposed to be part of the oxygen and carbon dioxide carrying component of the blood. In that scenario, the bone marrows could get messed up in a way that they cannot produce the RBCs at the rate the body requires. Leukemia, that is. ব্লাড ক্যান্সারের অনেকগুলো ভার্সন আছে, সো এটা যে সবসময় অ্যাডিটিভ হবে ব্যাপারটা এরকম না, কখনো কখনো এটা কি হতে পারে, সাবট্রাকটিভও হতে পারে, ওটাও প্রবলেম।
Yes sir, thank you sir.
Sure. চন্দ্রিমা বলো।
Sir, suppose the modified cell is a skin, like modified with the tumor cells যেটা ওইটা একটা স্কিন সেল বা সামথিং লাইক দ্যাট, তাহলে ওইটা ব্লাড স্ট্রিমে কিভাবে গিয়ে, হাউ ডাজ ইট লাইক স্প্রেড, ওইটা কিভাবে হয়?
বলতেছি, what you need to understand that every part of our body is an alive part of the body. Alive part of the body মানে হচ্ছে যে মনে করো আমাদের স্কিন যদি মনে করো let's say I'm not having a pedicure or manicure for let's say 1 month, I'm going to have a layer of dead cells on my hands. That's applicable for the entire body, to be honest. The most on the so that happens for the entire part of the body. Did you guys know that we eat a lot of part of our own self every day? Like we eat ourselves.
Sir, I fail to picture that.
Yes sir, no খাইনা।
Yes sir, phagocytes cells খাই ফেলে না?
No, actually eating our own selves. Let me put it this way. The locations where the mitosis is the most rapid in all of our external body skin is inside the mouth, the tongue, the gums and the inside of the mouth, they undergo the biggest amount of fastest rate of mitosis. Every single time we eat feed, we eat a lot of those cells. They actually get into our stomach, get digested, and gives us energy. That's what I meant, that we eat ourselves. Not.
I'm not kidding.
You can ask your biology teachers. I know this for a fact.
Question of it.
Okay.
Sir, 80% of dust.
বুঝি নাই। Gazi,
Sir, 80% of dust is dead skin cells.
Well, it's not that much. I mean, we don't eat that much that it will actually damage our system, but we eat quite a lot of our own body cells, which is created within our buccal cavity. That's what I was trying to mean. And also all the parts through which our food goes by. For example, the esophagus, then the stomach lining. All of these things are continuously getting digested because of all the process, right? It is continuously multiplying itself, and that multiplication is not extending the stomach on the outward side. It is extending the stomach on the inward side. But the stomach is not becoming smaller, or it's not getting filled up from the inside, because continuously those cells are getting digested by the whole food things and the hydrochloric acid and you name it. So you are, or we are, or I am continuously digesting parts of my own. That's a different part of the conversation. Every part of our body which is alive are definitely provided with blood circulation, because they need oxygen to work with, and they're also provided with some sort of nutrient supply so that they can essentially grow themselves. Most part of our body works with blood circulation, like capillaries and everything. There are certain parts of the body where blood cannot go. That's where the lymph nodes comes. The lymphatic system does the same job. That's a very small portion, but that also exists. That's a very important part as well. So every single place where you have a live cell, you have the transfusion of oxygen and nutrients. Do you agree on this part?
Yes, sir.
So you have a supply chain system that is connected to it. Somehow these cells might get detached from its original lump and enter into their supply chain system and become carried to other parts.
Okay. Yes, sir.
বুঝে গেছে?
Yes, sir. Thank you.
No problem. বলবান, তোমাদের কারো কোনো কোশ্চেন ক্যান্সারের পুরো গ্রোথ সিস্টেমটা নিয়ে? আমি এটা চিকিৎসা নিয়ে এখন কথা বলবো, সো ইফ ইউ আন্ডারস্টুড দিস পার্ট, আই ক্যান মুভ অন ফরওয়ার্ড। কারো কোনো কোশ্চেন না থাকলে নো লিখো, গিভ মি সাম রেসপন্স।
স্যার,
Nice, sir.
স্যার,
রাইট ইন দ্য chat window as public chat.
স্যার,
বলো।
স্যার, আমি ইউটিউব ভিডিও পরে দেখে নিব। আই ওয়েন্ট আউট, সো একটু ছোট করে ব্রিফ মনে দেয়া যাবে না?
এই যে আমি ধরো 16 মিনিট পর ক্লাস অফ করে দিই, ইউ ক্যান লিভ, সমস্যা নাই, তুমি পরে দেখে নিও, বাকি ঢুকাবো, কোশ্চেন থাকলে আমি কোশ্চেন করব, ইটস ওকে, ইউ ক্যান লিভ, ইটস ওকে।
না, আমি চলে গিয়েছিলাম, সো আই মিসড ইট। সো একটু ব্রিফ।
সমস্যা নাই, ইয়েস, না, হ্যাঁ সমস্যা নাই। না, ব্রিফ করে এখন বলতে গেলে অনেক কিছু বলতে হবে। তুমি ইউটিউব ভিডিও দেখে নিও, আমি তোমাকে সমস্যাটা পরে বলবো। So I have a response from about 1, 2, 3, 4, 5, 6, 7, 8, 9, 12-ish people. And there exist about 15 to 16 more people who did not give any response. একজনই 2-3টা করে রেসপন্স দিও না, তাকিয়ে আছে তুমি 2বার নো স্যার লিখছো, what is this? Okay, let's talk about how can we treat tumor or cancer. Now here comes the most messy part. The first thing that you need to appreciate that our body's basic immune system cannot kill the cancer cells. That is the whole point of having a cancer growth, which means somehow either you have to agitate the immune system enough so that it will be killing those cancer cells, or you have to physically, by some mechanism, you will have to kill those cancer cells. How do we achieve this? The most common mechanism by which we address cancer growth is by radiotherapy. Or radiotherapy essentially means a patient is put into a controlled gamma radiation chamber, and the location of the body where there is a tumor growth, to kill those cancer cells, we physically send high concentration gamma ray at that exact location, which disintegrates those cells at atomic level. Think about it. Let's say you have a lot of cancer cells. Cancer cell means what? There is a bond, atomic bond with one atom to another bond, which makes up the whole molecule, makes up the cell and everything. If you cannot kill it by your immune system, one of the ways we can do this is that we send extremely high powerful gamma ray radiation into this part. I mean, if you might feel like that, doesn't that produce more dead cell? Well, ideally we prefer to overcome that fact, but there is a catch. Catchটা হচ্ছে এরকম, জিনিসটা একটু এঁকে দেখাই, এই পার্টটা একটু দেখো। মনে করো হচ্ছে এটা হচ্ছে মনে করো একটা হাতের একটা ক্রস সেকশন, হাতের ক্রস সেকশন। মনে করো হাতের ভিতরে এই জায়গাতে একটা টিউমার হয়েছে, ঠিক আছে? এটা হচ্ছে আমাদের প্রবলেম। সো উই ওয়ান্ট টু সামহাউ কিক দ্যাট আউট। এখন আমি যদি একটা সিঙ্গেল গামারে এই বরাবর সেন্ড করি, এই বরাবর আমার যতগুলো সেল আছে সবগুলো মরে যাবে। বুঝছো কি বলছি? So to pinpoint this location, we don't do that. What the scientists do, yay. Okay, what the way it works is that if we, let's say we want to have an intensity is watt per meter square. It's a measure of the power of the or the concentration or the capability or the destructive power of the hydrogen out of the gamma photon, gamma beam. Let's say to kill these cells at atomic level destruction, we require to achieve 100 unit of destruction power at this location. So what they do, they can use 5 different sources, each of 20 unit of destruction power, and let's say they're gonna aim one in this direction, one in this direction, one in this direction, one is this direction, and maybe another one in this direction. So they're gonna use 5 different sources in 5 different directions, which are gonna travel with a destructive power of only 20 through the person's body, but they're gonna all focus at a single point where the tumor is located. So at this exact point, what will be the total value of the destruction power? That will be 100, right?
Yes, sir.
Yes, sir.
So this is basically one of the ways by which gamma radiotherapy or gamma radiation is given to the patient. If you wonder, well, this one of the reasons that the patient got to have cancer in the first place was gamma radiation. Then how do we actually handle with this thing, with cancer cells by gamma radiation? I mean, isn't that self-contradictory? It is, but here's the deal. The deal is, the reason this tumor got into existence in the first place, that our immune system could not kill it. So you have to physically kill it. So one of the ways you can physically kill it is by, if it's a small tumor, the basic process that the scientists go or the doctors go is they undergo a surgery and remove it physically, and you are pretty much good to go. If it has spread out over a larger region, let's say it has spread over a larger region like this, then moving this much flesh out of your body or this much part of an organ, let's say if it's in your lungs, or if it's in my lungs, if it's in my heart, or if it's in my kidney, moving this much part of the kidney is not maybe it's not actually logical. So they're gonna try to go for radiotherapy. Now, what the radiotherapy essentially does, it lowers the concentration of those cells. Let me put it this into perspective. মনে করো একটা এই certain লোকেশনে মনে করো তোমার let's say 2000 body cell আছে। Let's say এই 2000 body cell এর মধ্যে 1000 হচ্ছে cancer cell আর 1000 হচ্ছে healthy cell. Okay. Now, if we allow these 1000 cancer cells to exist here, let's say they're gonna become 2000 cancer cells over 1 month. I don't want this to happen. I want to reduce the number of these cancer cells to 0. That would be the best thing. But making it exactly 0 is not exactly possible, because you do not know exactly where they are. So what the radiotherapy is all about, we bomb this whole place. We bomb this entire place, which kills cancer cells, and also does a significant amount of collateral damage. Collateral damage means healthy cells also get killed. মানে যেটা হচ্ছে এরকম যে মনে করো USA is bombing certain part of Afghanistan to kill terrorists, but the terrorists are mixed up with the regular village people. Everyone is dead along with the terrorists, something like that. বুঝছো কি বলতেছি?
স্যার আবার বলবেন এই অংশটা?
I mean, we send the high energetic gamma rays to kill body cells into this entire region, in which case, in this process, we're going to try to kill these cancer cells, and these healthy body cells, they're also going to be killed. So the way we work is that we do molecular disintegration or atomic level disintegration to all the healthy cells and cancer cells alike for this region, which is, let's say this is a magnified view of this part. Okay. So, and also, I mean, this process is not done to a level that 100, 1000 or 1000 will be killed, because if you do that, this organ might become dysfunctional. So what the scientists do, they give this radiation over a duration of period so that the body can get enough time to heal itself from inside. That's why whenever someone undergoes radiotherapy, they have multiple sessions of radiotherapies. It does not happen on a single day. And also, let's say in 1 day of radiotherapy, this number of cancer cells gets down to, let's say, 500. Before the next session, let's say this 500 increases to 700, and then we give another radiotherapy, and let's say we then reduce it to, let's say, 350. Let's say after the healing process, this increase to, let's say, 400. Then we do another radiotherapy, and let's say in that process we make it to 200. So we are not essentially killing it altogether, but we are reducing the number of the alive cancer cells gradually. Do you understand what I'm saying?
Yes, sir.
All of them need to be vanished eventually, right?
We want all of them to be vanished, but we cannot kill all of them altogether, because this has a spread area. You cannot altogether kill the entire part of the organ, which might make that organ unstable or dysfunctional. Let's say 25% of the kidney has a cancer. Now, if you actually kill all the cells for 25% of a kidney, your entire kidney might become dysfunctional, which you don't want to risk. তা কি বলো?
স্যার আপনি বলছেন আমরা স্পেসিফিক ডিউরেশনের জন্য আমরা রেডিওথেরাপি দিব, স্যার তাহলে ওইটাতে হেলদি সেলস রিপেয়ার করতে পারবে, কিন্তু স্যার ক্যান্সার সেলস নিজেকে রিপেয়ার করতে পারে?
না না, হেলদি সেলস যেরকম মাল্টিপ্লাই করে, ক্যান্সার সেলও মাল্টিপ্লাই করে। আমরা ওই জায়গাটাতে কি রয়ে দিয়ে আমরা হেলদি সেলস এবং ক্যান্সার সেল দুটোকেই কিল করবো। দ্য ওয়ে ইট ইজ গোনা ওয়ার্ক, আই মিন দ্য আইডিয়া ইজ দিস, মানে জিনিসটা আমি তোমাকে বুঝাই। নরমালি বুঝো, মনে করো হচ্ছে তোমার একটা অনেকগুলি গ্রাম আছে পাশাপাশি, ঠিক আছে? অনেকগুলি গ্রাম আছে, অনেকগুলি গ্রামে অনেকগুলি মানুষ আছে। এখন মনে করো একটা গ্রামের মানুষের মধ্যে অর্ধেক মানুষ গুন্ডা হয়ে গেছে somehow. Try to visualize this in a planar view. Let's say you are looking from the helicopter, and তুমি যদি বোম মেরে এই গ্রামের ভালো মানুষ খারাপ মানুষ সবই মনে করো মেরে অর্ধেক করে দিলা। মনে করো হচ্ছে একটা গ্রামে টোটাল মানুষ আছে 2000, তুমি কোনোভাবে প্রসেস করে এখানকার এক্স্যাক্টলি 1000 মানুষ মেরে ফেললা। মনে করো 1000 মানুষের মধ্যে 500 মানুষ ছিল হচ্ছে গুন্ডা, 500 মানুষ ছিল হচ্ছে ভালো মানুষ। লেটস সে স্টিল স্পিকিং, তাহলে এখন টোটাল পপুলেশন তো 1000 হয়ে গেছে। বাট গ্রামে তো এখনো জায়গা আছে আরো 1000 মানুষ অ্যাকোমোডেট করার, যেটা হবে আশপাশ থেকে গ্রাম থেকে আরো মানুষ এসে এই বাকি 1000 ফিল আপ করবে। So you're going to increase the concentration of healthy cells and you're going to decrease the concentration of cancer cells. That's the process.
Oh, yes, I understand. Yes.
You cannot entirely obliterate that, because if you obliterate the total 2000 population in a single go, that entire village will become haunted, dysfunctional. You don't want that to happen. You want to repair it, not wipe off. নাইম হায়দার বলো।
আচ্ছা স্যার, যদি একটা সিচুয়েশন থাকে যে ধরেন কিডনি কথাই বলি, যদি অনেক সেল যদি এফেক্টেড হয়ে যায়, তখন যদি তারা অলটুগেদার সব মেরে ফেলতে চায়, তাহলে কিডনি হচ্ছে ডিসফাংশনাল হয়ে যাবে। কিন্তু যদি এমন হয় যে কিডনিটা এখানে ক্যান্সার রেখে দিলে মানুষের লাইফের ঝুঁকি থাকতে পারে, তখন কিডনিটাকে ডিসফাংশনাল করার রিস্কটা কি নেওয়া এটা না একটা? তখন তো
হ্যাঁ, I get your point. I brought about the example of kidney exclusively for one reason, that কিডনি শরীরে আছে দুইটা, একটা কিডনিতে ক্যান্সার হয়েছে, এই কিডনি এখান থেকে ছড়াতে পারে, ওই কিডনি কেটে ফেলা দিলাম, আরেকটা কিডনি দিয়ে মানুষটা তার বাকি লাইফ পার করলো, হইতে পারে। কিডনির জন্য এটা অ্যাপ্লিকেবল, বা এটাকে হার্টের জন্য অ্যাপ্লিকেবল, স্টমাকের জন্য অ্যাপ্লিকেবল, বা ব্রেনের জন্য অ্যাপ্লিকেবল? নো। I chose the example of kidney to give you this part of the example, that if you have something spared that you can work around, then you can get rid of that organ by surgery and get rid of it altogether, just so that you can live better. But that's not possible for all the organs. Now, বুঝতে পারছি তোমার কোশ্চেন আনসার পাইছো?
জি স্যার, জি।
Okay. So this is the whole idea of radiotherapy, by which we can kill this thing. So and you can also ask me that in the process of radiotherapy, isn't it possible that we will develop new type of cancer cells because we are sending high energetic gamma photons? So shouldn't they be able to produce new cancer cells? The answer is yes. That's the whole point of continuing this process. You cannot stop your radiotherapy at halfway point, because that might actually make your situation much more worsen. You have to continue this process to the prescribed level of your physicians and do the process in a proper mechanism, so that you do not get overdosed, you do not get underdosed, you get the proper dosage of radiation over the period of time, so that it can be finished properly and you can have a much lower count of cancer. Your cancer can be in control. My cancer can be in control. The patient's cancer can be in control. That's the important part of radiotherapy. So using radiotherapy, we cannot cure cancer, but we can control cancer, or we can reduce the effect of cancer that is happening on the patient's body, or he can have a much more regular life.
We can kill, right? Eventually.
I mean, that depends on at which level did we start. And for example, let's say this is 2000. Let's say up till the point that we human beings have developed the mechanism to deal with cancer. Let's say we can use radiotherapy up to a population of, let's say, 10,000. ঠিক আছে? And 10,000 বা 10,000 এর কম যদি আমাদের টোটাল ক্যান্সার সেল কাউন্ট হয়, তাহলে আমরা এটাকে রেডিওথেরাপি দিয়ে হ্যান্ডেল করতে পারবো। বাট লেটস সে সামওয়ান গেটস দেয়ার ক্যান্সার ডিটেক্টেড এট আ লেভেল অফ 1 মিলিয়ন, তখন রেডিওথেরাপি দিয়ে লাভ নাই। আইদার তোমাকে তখন 1 মিলিয়ন না, আগে তো ঠিক লিখছিলাম, সরি এখানে হ্যাঁ
কি দিন গুনবে।
হ্যাঁ, মনে করো এই লেভেলে এসে কার ক্যান্সার ডিটেক্ট হলো, স্টেজ 3 or stage 4, ঠিক আছে? তো তখন তাকে আসলে খরচের খাতে হিসাব করে ফেলা ছাড়া কিছু করার নাই। But if cancer gets detected at a very early stage, then you can go for protective methods.
খুব রিস্কি একটা মেথড না, যে ধরেন এটা ইরেডিকেট করলাম, ওই 1000 থেকে 200 তে নামাই ফেললাম, বাট অ্যাজ আ রেজাল্ট the others get cancerized and they become the same thing.
Well, one of the things is that once you make this thing reduce to 200, typically what the scientists prefer to do is, let's say they have a count and they also check the genetic code of those materials by doing biopsy every once in a while. So they will do this thing, and once they are convinced that the number of population has become small enough, they will do an actual surgery to remove the part that they deem cancerous. মানে removing this entire part of the body was not maybe safe, but maybe by doing radiotherapy, you are slowly reducing the concentration. So your cancer cell growth region is becoming smaller and smaller and smaller. At one point, it is safe to do undergo surgery, and then they'll do the surgery and remove it altogether.
So 4th stage money you are done for.
Typically, 3rd and 4th stages they both mean they are done for. I mean, the first stage means that you have a undetected tumor in your body which is not acting up very well. Second stage typically means that you have a tumor that is going up very fast, but that tumor is entirely limited to one location of your body. One location of your body. It means it has not entered in your bloodstream anyhow. Okay. Third stage typically means that these cells have started to go around your body, and they are trying to exhibit tumor growth in different parts of your body. This is just this process has begun. This is what we call stage 3. Stage 4 is where this cancer is affecting multiple vital organs of your body. That's stage 4. That's what I know. So my knowledge might be limited or wrong, because I'm not a doctor or an oncologist, but this is what I know from my earlier study. So I'm not vouching for this information, but that's what I know. You can look up for better information at your own time. Any questions so far?
No, sir.
No, sir.
Clearly বুঝা গেছে?
Yes, sir.
Yes, sir.
আমি usually রেডিওথেরাপি ক্লাসগুলোতে এই ফিজিওলজিক্যাল জিনিসগুলো সহ আলাপ করি, because it makes the picture so clear that kids usually are able to answer questions naturally. So many of you might feel a bit bored that আমি প্রচুর কথাবার্তা বলছি আজকে কিছু লেখা দেখাচ্ছি না, but that's usually how I prefer to. আচ্ছা হাফ লাইফের ক্যালকুলাস আমি নেক্সট ক্লাসে দেখাবো, তোমাদের একটা সার্টেন পার্ট পড়তে দেই, এটা পড়া শেষ হলে আমরা আজকে ক্লাস ক্লোজ করতে পারি। এখানে হচ্ছে এই যে আচ্ছা এখান থেকে পড়ে যাও, ইন্ডাস্ট্রিয়াল পার্টটা আমি তোমাদের পরে বুঝাবো। ইন্ডাস্ট্রিয়াল পার্টটাও পড়তে পারো, সমস্যা নাই, পড়তে পারো, এটা আমি এখনো বুঝাইতে পারি, সমস্যা নাই। একটু পড়ো।
এখন পড়বো?
হ্যাঁ
শুরু করব কোথা থেকে? কিডিং থেকে?
ইয়েস
স্যার, আপনি হাফ লাইফ পড়াইছিলেন
না? হাফ লাইফ নেক্সট ক্লাসে পড়াবো, ম্যাথমেটিক্যাল ক্যালকুলেশন করে নেক্সট ক্লাসে দেখাবো। মানে আমি হাফ লাইফটা চেষ্টা করতে চাইতেছি যে একদম লাস্টে পড়ে ইমিডিয়েটলি ওয়ার্কশিট ঢুকে যেতে, বাট যাতে করে ওই ম্যাথের মেকানিজমটা আমরা ইমিডিয়েটলি প্র্যাকটিস করে ওয়ার্কশিট স্টার্ট করে ফেলতে পারি। ওই জন্য হাফ লাইফটুকু আমি স্কিপ করে অন্য জিনিসপত্রগুলো পড়াই যাচ্ছি।
স্যার ওয়ার্কশিটটা দিয়ে দেন স্যার, প্রিন্ট করে।
আচ্ছা ঠিক আছে, তোমাদের আমি তোমাদের বুকলেট বানানো মনে হয় শেষ করছি। তোমাদেরকে কিছুদিনের মধ্যে আমার কোচিং আসার একটা ডেট দিতে পারি। তোমরা 2 থেকে 3 ঘন্টার মধ্যে কোচিং এ কালকে পাঠায় বা হচ্ছে নিজেরা এসে বা প্যারেন্টস থেকে পাঠায় তোমরা ওয়ার্কশিটগুলো কালেক্ট করে নিবা। দিস ইজ what is very helpful for me because this is what Tulansa did yesterday for a lot of kids, and apparently it was very moving. That's what Mamun told me, and that can be achieved. And for those who really cannot do this, I mean you don't have the means of people to make this happen, I will send you to them by part of services, but I would appreciate if you show up or at least send someone to pick up your stuffs. I'll declare that date pretty soon. আমি এখনো প্রিন্ট করে সব বাধাই টাধাই করার প্রসিডিউরে আছি, so you'll be receiving I hope a pretty nice booklet that might as well look something like this.
নেসেসারি আমাদের না সিলেবাস শেষ প্রায়, আর কোশ্চেন পেপার তো সব দিয়ে দিচ্ছে।
আমি তো পিডিএফ দিছি, বাট অনেকে এগুলো এখন প্রিন্ট ফরম্যাটে প্রিন্ট করে না, বা দে উড স্টিল লাইক টু হ্যাভ দ্য প্রিন্ট আউটস, সো ইয়া।
সো যাদের প্রিন্ট আউট আছে তাদের কি যা লাগবে স্যার?
If you don't need it, it's not essential, but you can collect it. If you want a fresh copy of it, blank copy of it from at any point, you can ask for it and have it. For those of you who don't want it, you don't have to come. It looks something like this. I made a pretty nice booklet. It looks like this. This is the class 9 booklet, and inside it looks like this. This is the note from one of the then the MCQ paper, then the mark scheme, then the paper 2.
নোট সহ দিবেন একবারে?
আমি এভাবেই দেওয়ার প্ল্যান করছি এবার। মানে এটা হচ্ছে ক্লাস 9 এর ফুল বুকলেট ফর দা ওই যে ডেনসিটি প্রেসার পর্যন্ত তোমাদের একবারে যে ফাইলটা দিছিলাম ওই জিনিসটা এবার ফাইলে না দিয়ে আমি রিমাইন্ডিং করে দিয়েছি।
ফুল
জোসা
স্যার এর মধ্যে কি নোটসগুলো থাকবে একদম প্রথম দিন থেকে শেষ দিন পর্যন্ত?
I really hope to incorporate them.
স্যার ফুল কিভাবে? এটা
তো অনেক ভালো হয়।
I really hope to do that. I mean I'm working towards that.
স্যার
বলো।
আমার পেমেন্ট নিয়ে একটা কোশ্চেন ছিল।
পেমেন্ট নিয়ে?
यस স্যার।
স্যার আমার কোশ্চেন ছিল স্যার।
বলো।
স্যার যে কি বলে আপনার ব্যাংকের নাম দেব সিটি ব্যাংক, আর জাস্ট অ্যাকাউন্ট নাম্বারটা দিয়ে দিলে হবে বিকাশে নাকি?
তুমি কি বাসা থেকে বিকাশ করবা?
হ্যাঁ।
শোনো, বিকাশের মেনুতে গেলে তোমার মোর একটা বাটন আছে, উপরে তো 4টা অ্যাকাউন্ট দেখায়, তুমি মোরে যাইতে হবে। মোরে গেলে ওখানে ব্যাংক ট্রান্সফার নামে একটা আইকন আসবে, ব্যাংক ট্রান্সফারে যাবা। ব্যাংক ট্রান্সফারে গেলে ওরা জিজ্ঞেস করবে সেলফ না আদার, তুমি দিবা হচ্ছে আদার দিতে হবে, বিকজ দিস ইজ নট ইওর অ্যাকাউন্ট, দিস ইজ মাই অ্যাকাউন্ট। আদার দেওয়ার পর জিজ্ঞেস করবে কোন অ্যাকাউন্ট, ওখানে 2টা অ্যাকাউন্টের আইকন আছে, সিটি ব্যাংক অথবা হচ্ছে ব্র্যাক ব্যাংক। সিটি ব্যাংক সিলেক্ট করবা, মানে জাস্ট আইকনে প্রেস করবা, তারপর বলবে অ্যাকাউন্টের নাম কি, অ্যাকাউন্টের ইনফরমেশন কি, যেটা আমি তোমাদেরকে যে শেয়ার করছিলাম, বা চাইলে আমি পার্সোনালি পাঠিয়ে দিতে পারি, যে এখানে আছে, এটা আমার সব পুরোটা লেখা, এই যে এখানে পুরো লেখা আছে। এই হচ্ছে
আর কিছু চায় না?
না, এই দুটাই চাই। এটা হচ্ছে অ্যাকাউন্ট নেম, এটা হচ্ছে অ্যাকাউন্ট নাম্বার, এই দুটো ঠিক আছে। এই দুটো তুমি অ্যাড করবা, অ্যাড করার পর ওরা কিছুক্ষণ একটু ওয়াইফাই চেক করবে, ঠিক আছে দিস অ্যাকাউন্ট হ্যাজ বিন অ্যাডেড, তারপর তুমি হচ্ছে এটা অ্যাকাউন্ট অ্যাড হয়ে যাবে, তারপর ওই অ্যাকাউন্টে চাপ দিই, তারপর তুমি টাকাটা পাঠিয়ে দিবা। এই
কোনো ব্রাঞ্চ নাম্বার লাগবে না?
ইউজুয়ালি ওরা ব্রাঞ্চ চায় না, আমি এখন পর্যন্ত দেখি নাই। মানে টু বি অনেস্ট এইটার ভিতরে কিন্তু ব্রাঞ্চটা সব দেওয়া আছে। দিস কোড ইজ সেলফ সাস্টেইনড।
ওকে,
মানে তুমি যদি বাংলাদেশ ব্যাংকে গিয়ে এই কোডটা বলো, তারা তোমার বলে দিতে পারবে যে তোমার অ্যাকাউন্টটা কোন লোকেশনে, তোমার অ্যাকাউন্টটা কোন ব্যাংকে, মানে দিস কোড হ্যাভ এভরিথিং। বাট স্টিল কিছু অ্যাপে সফটওয়্যারে অ্যাডিশনাল জিনিসপত্র, যে কোন ব্যাংকে কোন ব্রাঞ্চে বাবার নাম কি, মায়ের নাম কি, ক্রিডেনশিয়াল ইনফরমেশন
হ্যাঁ
কিছু
স্যার
চায়, ঠিক আছে, এগুলা কিছু চায়, কিছু অ্যাপ এরকম করে ডেভেলপ করা আছে ফর সিকিউরিটি পারপাসেস, বাট অল দ্য অ্যাকাউন্ট ইনফরমেশন আর এমবেডেড উইদিন দিস থিং, মানে হুইচ অ্যাকাউন্ট ইট ইজ এটা ডিটেক্ট করার জন্য এই নাম্বারটা যথেষ্ট।
ওকে
ঠিক আছে, আচ্ছা এটা আমি নেক্সট ক্লাসে বুঝাবো, আজকে অনেক কথা বলে ফেলছি, হরান লাগতেছে, আজকে আর না করি। হ্যাঁ বলো, পেমেন্ট নিয়ে আরেকজনের জন্য কি কোশ্চেন করতে চাইছিলাম?
এই পেমেন্টটা কি কোনো আপনার মানে পোস্ট দিয়েছিলেন ফেসবুক গ্রুপে কিংবা মেসেঞ্জারে?
No, I have this whole thing written down in my notepad, which is on my desktop. If you want, I can just do this, and then I do this, and I can send it to you personally. So if you need any payment update mechanism, you can ask me. মানে এখানে আমার সিপি অ্যাকাউন্ট আছে, এখানে আমার দুটো বিকাশ নাম্বার দেওয়া আছে, এবং আমার কিছু হাবিজাবি কথাবার্তা বলে দেওয়া আছে এইসব।
গ্রুপে দিয়ে দেন তাহলে কপি করে।
গ্রুপে দেওয়াটা আমার কাছে ছেঁচড়ামি লাগে। If you want it, you ask me. I'll give you personally.
আচ্ছা ঠিক আছে ছেচড়ামি কি স্যার, আমরাই তো।
I know, but still মানে কিছু পাবলিক আছে না বেশি বুঝে, ধরো এই অ্যাসপেক্ট আমি একটু বেশি বুঝতেছি আর কি, accept it that way.
আচ্ছা ঠিক আছে
বলো, আল্লাহ হাফেজ, have a good night.
Bye sir.
Bye.
Bye, sir.
Bye sir.